Hello, this is homework chapter 6. In this session, we'll be doing the first three problems, 39, 43, and 47. Problem 39. In the men's weightlifting competition of the 2008 Beijing Olympics, Matthew Steiner made his record lift of 446 kilograms from the floor to over his head 2 meters. How much work did Matthew Steiner do during the event? All right, the work is equal to the force times the distance times the cosine of the angle between them. So we have the force is mg, the weight, times d, times cosine of 0. So we get 446 kgs times 9.8 meters per second squared times 2 meters times cos 0 is going to give us 8,700 joules. That was 39. All right, number 43. The statue of Isaac Newton is created and moved here from the Oxford Museum of Natural History and Science for cleaning. The mass of the statue in the crate is 150 kilograms. As the statue slides down a ramp inclined at 40 degrees, the curator pushes up parallel to the ramp surface, so the crate does not accelerate. If the statue slides 3 meters down the ramp, and the coefficient of kinetic friction between the crate and the ramp is 0.54, calculate the work done on the crate by each of the following: gravity, the curator, friction, the normal force between the ramp and the crate. All right, let's go. Gravity. All right, for gravity, we have the work equals mg mg cosine theta, mgd cos theta. All right, so we have 150 kgs times 9.8 meters per second squared times 3 meters, was it? Yeah, 3 meters. Times cosine of 50, because it's 90 minus 40. And that would be 2.8 times 10 to the third joules. And here's the free body diagram for the gravity goes this way. This angle's 40, that's 50. Yeah, a little confusing. The cos 50 is the same as sine 40, which is what is used to solve the next one. So now we have to find the work done by the curator. So we have no overall force. So we have the force of gravity, F, the work done by gravity, sum of the forces minus the force of friction minus the force from the curator equals 0. So we have, let's see, the work done by the curator equals the work done by gravity minus the work done by friction. And our workup, let's see, it's going to be negative because we're going against the force. So we have mg sine 40 times 3 meters minus mg cos 40 times 3 meters times the coefficient of friction, 0.54, 0.54. And that's going to be, let's see, what do we have? All right, so our work done by the curator is going to be the difference between the work done by friction, which is pushing it down, minus the work done by, the work done by gravity, which is pushing it down, minus the work done by friction, which is pushing it up, going against that. But it's also going to be negative because we're going against the force. So we're going to put a negative there. And if you do the math, the answer is going to be negative 1.0 times 10 to the third joules. All righty, that's part B. The work done by friction is also going to be negative. It's going to be the mg cos 40 times 0.54, the coefficient of kinetic friction, times the distance, 3 meters. And that is going to be negative 180, negative 1.8. It's going to be well, you could say the cos 180 here because that makes it negative. That just negative 1, right? It's going the opposite direction, times 10 to the third joules. All right, and that is part C. In part D, we're asked to determine the work done by the normal force. The work done by the normal force is 0 because it is perpendicular to the direction of motion. The direction of motion is here. The normal force is there. Cosine of 90 equals 0. That was 43. Number 47 asks, a bumblebee has a mass of 25.25 grams. If its speed is 10 meters per second, calculate its kinetic energy. All right. So the kinetic energy is 1/2 mv squared. The weight is 0.25 grams. So we have 1/2 times 0.25 times 10 to the negative third times 10 meters per second quantity squared. And our value is going to be 1.1 times 10 to the negative 2 joules. All right, and that concludes the first half of the homework. 30.